Alright, so in this video today, we are talking about another type of factoring, but this polynomial that we're going to factor looks different than the other polynomials, and I want to point that out before I go through and explain how to factor, and it's called factor by grouping. I know by now we've gone through a couple different ways of factoring, and I know some people have reached out and said that it's getting challenging to figure out how, which method to use and how to factor. So I want to point something out that hopefully will make this a little helpful. The polynomials that we're working with today in our new notes with factor by grouping is going to be 4-term polynomials. So factor by grouping, this process only works when we have 4 terms in the polynomial. So when we have 1, 2, 3, 4 terms. And you'll notice that today on all four examples are 4-term polynomials, okay? So this process only works on 4-term polynomials. So how does it look different? Well, our x squared plus 7x plus 12 is a 3-term polynomial, right? So look at the difference between this polynomial here and the polynomial we're going to work with today, okay? So when you see polynomials with 4 terms, you're going to use the factor by grouping method, which is what we're talking about today. So, factor by grouping. It's similar to the idea of finding a GCF. So our factoring roadmap always comes into play. You always want to look for that GCF first. You want to get it as fully simplified as you possibly can before you try and apply any factoring method. So the first thing you want to do is look at every single term, and you want to determine of whether or not they have a GCF. And the answer is no in this first example. So factor by grouping, because it's a 4-term polynomial, means we're going to take 2 sets of parentheses and we're going to put it around the first 2 terms, and then we're going to put a second set of parentheses around the second 2 terms. Okay? What we're going to do now within these sets of parentheses is find a GCF just between these 2 terms. So we have 4n cubed plus 8n squared. Well, what's a GCF between these 2 terms? It's going to be 4n squared. Okay? I'm going to factor out that GCF from these 2 terms. So when I factor it out, again, we divide. So 4n cubed divided by 4n squared leaves me with n. 8n squared divided by 4n squared leaves me with plus 2. With me so far? All we did was group the first 2 terms, and we grouped the last 2 terms in parentheses, and then all I did was find what the GCF of this first set of parentheses is, and I factored it out of those 2 terms. We're going to follow the same process for the second set of parentheses. So negative 5n minus 10. What's our GCF? Well, our GCF is going to be negative 5. Okay, and notice how I just kind of wrote it out here like minus 5. Okay, I'm going to factor it out of my 2 terms. So negative 5n divided by negative 5 gives me n. Negative 10 divided by negative 5 gives me plus 2. And something that you should notice, and something that should happen every single time, my 2 sets of parentheses now are the same. All right, and that's something that should happen every single time you factor by when you are doing factor by grouping, okay? That's why I took out negative 5 and not positive 5. So because I saw that they were both negative, I could take out the negative 5 versus the positive 5, all right? If I didn't take out negative 5 and I took out positive 5, I would get negative n minus 2. That would not be the same as n plus 2. Okay, so that's why I had to take out the negative 5, so that way my 2 sets of parentheses would be the same. Now, n squared, parentheses, n plus 2. This is 1 term, and then negative 5n plus 2 is a second term. What do these two terms, here, I'm going to use pencils that way I can erase it. I'll try and draw like an invisible line here. What do these two terms have in common? What is identical between the two terms? It's going to be whatever's in that set of parentheses. So again, my two sets of parentheses are acting like a GCF because it's common in both terms. So I can factor that out. So I'm going to go ahead and factor out my n plus 2 from each term, okay? And when I factor it out, all I'm going to have left is 4 n squared minus 5, okay? In this case, this is done. That's all we can do. Okay? Now, it's important to check that when you get down to this stage and you get down to where you have two sets of parentheses, you have to make sure that no other rules apply. Make sure it's not a difference of two squares. Make sure it's not a perfect square trinomial. Make sure it's not factorable in any way, shape, or form from here on out. That's what fully simplified means, or fully factored means. Okay, so let's do another example. Looking at this polynomial, okay, again, we're going to split the polynomial in half. We're going to group the first two terms and then group the second two terms. So group the first two terms with a set of parentheses, and then group the second two terms with a set of parentheses. Looking at the first set of parentheses, we want to factor out a GCF. So we have 5t to the fourth plus 20t cubed. My greatest common factor is going to be 5t cubed. I want to factor that out, which means I want to divide it out, so I'm going to be left with t plus 4. Now we want to look at the second set of parentheses. We have 6t plus 24. Our GCF is plus 6, or positive 6. So I want to write plus 6. What do I have left when I factor that out? I'm going to have t plus 4. Again, I want to make the note that these two sets of parentheses need to be the same. They should be the same when you factor it out. Otherwise, there's another GCF, or you didn't factor it out properly. Okay? So now, again, kind of split. This is one term, and this is a second term. What do they both have in common? They have the set of parentheses in common. So we're going to go ahead and factor that out. So t plus 4, so I'm going to take out this t plus 4 and take out that t plus 4. And I'm going to be left with my 5t cubed plus 6. Okay? 5t cubed plus 6, I can't do anything with that. So I'm fully factored. I do want to take a step back to this first problem again, and I kind of want to talk about this 4n squared minus 5. This term right here is a perfect square, okay? The 5 is not. So if the 5, let's say, was a 25, for instance, and this said 4n squared minus 25, that would be a difference of two squares, which would mean I would have to continue to factor. But because this is not, we stop there. All right, two more examples. Okay, here we go. Again, first thing we always do, we always look to see if there's a GCF across all of the terms before we try factoring anything. Okay, so 12p to the fourth plus 10p cubed minus 36p squared minus 30p. Well, they all have p, so I can take out 1p from each term, and I think the highest factor they have in common is 2. So let's take out 2p from the entire polynomial. Okay, so we're going to be left with 6p cubed plus 5p squared minus 36 divided by 2. My brain's not operating. 18. So minus 18p minus 15. Okay, so that's my polynomial that's left over. I am going to still follow the same process we just did. Okay, the only difference is that I had to factor out that GCF from each term first. Now I'm going to continue with my factor by grouping. So here we go. I'm going to do it in green. So I'm going to group these first two terms together, these second two terms together. Okay, my 2p just comes along for the ride. We don't do anything with it anymore. So it's going to stay there. It's going to stay as 2p, big set of parentheses. Okay, now 6p cubed plus 5p squared. We need to find what the greatest common factor is. 6 and 5 have no greatest common factor between them other than 1. And then we have p cubed and p squared. So my greatest common factor is going to be p squared. When I factor out my p squared, I'm going to have 6p plus 5, close my parentheses. Now I have negative 18p minus 15. Again, I need to make sure that I get my 6p plus 5 left over when I factor out my GCF. So the greatest common factor is going to be negative 3. So then I get 6p plus 5, okay? And then I'm going to go ahead and close my really big set of parentheses with that 2p. Okay, so remember, this is just all inside my big set of parentheses with 2p, but we're basically ignoring 2p otherwise. All right, so here we go. 2p is coming along for the ride again. Big set of parentheses, all right? Again, my smaller set of parentheses on the inside is still the same, so that's not changing, all right? I'm going to go ahead and factor that out of my two terms. So just like we did before, we split it in half. I want you to just look at this term and then just look at this term. They both have that 6p plus 5 in common. So 6p plus 5. And then what do they have left over? P squared minus 3. Right? And I'm going to go ahead and close that set of parentheses. And I want to look and see, okay, is there anything else I can factor? Is this a difference of two squares? No. Is there anything else? Nope, that's it. That's all we can do. So that is our fully simplified and our fully factored polynomial. Okay. What I want you to do at this point is pause the video and I want you to try this last one on your own. And then click play, and then I want you to go through and double check your work with mine. All right, so hopefully you gave this problem a try. This problem is very similar to the problem we just completed. So we want to look for that GCF first between all of the terms, and then we're going to go ahead and factor by grouping. So 45m to the fourth minus 9m cubed plus 30m squared minus 6m. So we are looking at m as a common factor between all of them, and we are also looking at 3. So let's go with 3m factored out. We're going to get 15m cubed minus 3m squared plus 10m minus 2. Okay, and now we're going to go ahead and break down this polynomial into two sets of parentheses. We'll leave my 3m alone, so 3m, big set of parentheses. I want to find my GCF just between this first group. 3m squared. And that leaves me with 5m minus 1. 10m minus 2. Let's go with negative 2. So I get 5m. Oh, plus 2, I'm sorry, not minus 2. So that gives me the 5m minus 1. All right. Again, good check for yourself. 5m minus 1, 5m minus 1. My 3m comes along for the ride, but then stays there. 5m minus 1 gets factored out, and then I'm left with 3m squared plus 2. I don't have a difference of two squares. I don't have any other combination that would allow me to factor any further, so I'm done.